Hey there, and welcome. The ground right under your feet might seem pretty solid, pretty permanent, but what if I told you it holds an absolutely epic story? A history of our entire planet, written in a language of stone. Well, today we're going to learn how to read it.
So let's just start with this question, right? The Earth is 4.6 billion years old. That is a number so big it's almost impossible to wrap your head around. So how on earth do you even begin to read a story that long? A story with no words, no pages, no author.
Well, it turns out the clues are literally everywhere. They're all around us, written in this language of stone. And geologists, they're kind of like the master detectives who've spent centuries learning how to read it, piecing together the planet's past one rocky clue at a time. And today, we're joining the investigation.
Now, every good detective needs a set of rules to crack a case. And in geology, the most fundamental rule of them all is about how to read the layers. It's called the principle of superposition. And honestly, it's so simple, it's brilliant. In any stack of rock layers that hasn't been disturbed, the oldest stuff is always at the bottom, and the youngest, newest stuff is at the top. I mean, think about a laundry basket, right? The clothes you threw in on Monday are at the bottom, and what you wore today is right on top. Rocks work the exact same way.
And if you want to see this in action, just look at the Grand Canyon. It's like a giant open history book. Each one of those incredible colored bands is a different chapter, a completely different environment from Earth's deep past, all stacked one on top of the other. You're literally looking back in time as your eyes move from top to bottom.
And that simple principle is our key. It's what allows us to unlock this almost unimaginable timeline. It lets us put all those rock chapters in the right order so we can build a cohesive story that spans all 4.6 billion years of Earth's history.
Okay, so we know how the chapters are ordered, but what are they actually written in? Well, the language of this story is the rock itself, and it basically comes in three main dialects, or types. If we're going to be detectives, we've got to learn the language. First up, igneous rocks. These are the ones literally born of fire. They form whenever molten rock, whether it's called magma when it's deep underground, or lava when it erupts under the surface, cools down and hardens into a solid.
And here's the cool part. How it cools tells its own story. If that magma cools really slowly deep inside the Earth, we call it intrusive. It has time to grow big, beautiful crystals you can easily see. But if it erupts as lava and cools super fast on the surface, we call it extrusive, and the crystals are so tiny you can't see them at all.
A perfect example of this is granite. You've seen this rock 1,000 times. It's in kitchen countertops, fancy buildings. Those big, sparkling, coarse grains are a dead giveaway. They're telling you that this rock formed slowly, miles beneath the surface, long before it was ever pushed up for us to find.
All right, our second type of clue is sedimentary rock. And if igneous rocks are the fiery beginning, these are the history keepers. They're made from all the little bits and pieces, sand, shells, fragments of other rocks that get broken down, carried around by wind and water, and eventually settle down in layers.
This whole process is like a slow-motion dance that takes millions of years. First, you've got weathering and erosion, which just means older rocks get broken down into tiny bits. Then, those bits get carried off and dropped somewhere else. That's deposition. Over time, the sheer weight of all the layers piling on top squeezes them together. That's compaction. And finally, minerals that are dissolved in water act like a natural superglue, cementing everything together into solid rock.
And here is why sedimentary rocks are a detective's absolute dream. Because they form from all this settled material, they can trap and perfectly preserve things that were on the surface at the time, like plants and animals. They're basically treasure chests filled with fossils, giving us our clearest window into the history of life itself.
Just take sandstone, for instance. It's basically fossilized sand. When a geologist finds a thick layer of sandstone, they're not just seeing a rock. They're seeing the ghost of an ancient beach or a long-gone riverbed, or maybe even a vast desert from millions and millions of years ago.
So that brings us to our third and final clue type, metamorphic rock. The name pretty much says it all. Meta means change, and morph means form. These are the shapeshifters. They're rocks that started out as something else, igneous or sedimentary, but were later transformed by some truly incredible forces.
And what kind of forces are we talking about? Well, we're talking about intense baking heat from nearby magma, or the crushing extreme pressure of being buried miles deep inside the Earth's crust, or even being cooked by superheated fluids. These things don't quite melt the rock, but they cook it and squeeze it so hard that all its minerals realign themselves into these cool, wavy bands.
A classic example of this is marble. It actually starts its life as limestone, which is a pretty common sedimentary rock. But when that limestone gets buried, baked, and squeezed deep within the earth, its whole structure gets rearranged into the beautiful crystalline marble that we use for statues and buildings. It's a total transformation.
So, let's do a quick recap. We've got our three main types of clues. Igneous, born from fire, with that crystalline structure. Sedimentary, layered over time, and they're the ones that hold the fossils. And metamorphic, the transformed rocks, changed by intense heat and pressure. Each one tells a really unique part of Earth's story. Okay, so this is all really fascinating, right? We can read the rocks, we can uncover this ancient history. But so what? Why does any of this matter to us today? What are the real stakes of all this geological detective work?
Well, turns out understanding this story is absolutely critical. It tells us where to find the minerals and energy we need to run our world. It helps us find and protect our precious water supplies. By reading about past climates in the rock record, we get a much better handle on the climate change that's happening right now. It even tells us the safest places to build our homes and cities.
And on top of all that, it helps us understand and prepare for some of nature's most powerful forces. The cracks and faults in the rocks, they tell us where earthquakes are likely to happen. The type of rock, it can warn us about potential landslides or volcanic eruptions. Reading the past literally helps us protect our future.
But here's the most amazing part. This whole story, it's not over. Not even close. In fact, it's a never-ending cycle, a dynamic process that is happening right now, all around us, constantly rewriting the planet.
It's called the rock cycle, and you can think of it as Earth's ultimate recycling program. Any rock on the surface can be worn down into sand and mud, which can then become a sedimentary rock. That rock can get buried and transformed into a metamorphic rock, and that rock can get pushed so deep that it melts back into magma, ready to start the entire process all over again as a new igneous rock. It's an endless loop.
And that brings us to maybe the most incredible realization of all. The Earth is not a finished book. It's a living, breathing document. The ground you're standing on right now is part of this amazing, slow-motion cycle of creation, destruction, and renewal. Which leaves us with one final, mind-bending question. What story is being written in the rocks, right here, right now?